this episode of Finno-Ugric Machining, we are finally going on with this rotating welding positioner. And what we are doing today, we are, attaching the motor to the body of this thing. And maybe we are able to rotate it for the first time. Well, here is the rotating welding positioner body, and strictly speaking, it's rotating already. It's not motorized. Now what we need to do is to attach the motor to this body. And I made at some point this piece of thing which goes about here. And as you can see, it has this round shape which has the same radius as has this body. So, and then it has 5 6mm holes. There will be 6 studs. No, totally wrong. There will be bolts, not studs, and there will be only 5 of them, not 6. Going through and attached to the body so that you put it here, put some nuts on there, and after that it will stay in place. But the big question is where? Okay, lucky me, this isn't exact science, so it doesn't need, the tolerances in this case are really small. And again, not small tolerances, maybe loose tolerances is the correct word. Well, of course the tolerance, this is now the motor output gear, yeah. And there is a taper inside there where it attaches to, like this. And then I just put it somewhere here. Now I try to align it about in the correct place. Well, I believe that's our correct place, and then I take a scribe and make a line here. Hopefully I can see it later on. Let's see now if I can see it. Yes, I can see it's there. Okay, now we know the place. We have to dismantle it, so, and this is really heavy, so. Oh. Oh yeah. Okay, now attaching this to the table. Well, it's a little bit complicated, not much, but a little bit. So I will use this machinist vise, and then I use this 2 clamp here. Whatever strap this is goes there. And then we have this, which goes there. This goes behind here to a suitable height. Well, it's about the suitable height there. Okay. Now I just align these straight about, this is in about the correct position. So I tighten these lightly, which actually will, I have the other side ready here already. So, and now this is not well in place. The reason is that if there becomes a bending force like this, it will break my table. So I need to put these in place in a way that they support the thing. I'm here trying to align them direct. There you are. Tighten them just a little bit. I think there it is. And then I can tighten this fully. And now it supports it from here, from the sides, so it doesn't rotate easily. So now it's attached on 3 points on each side. So that should be enough to hold it in place and not break my table. Let's see this one more time. Yeah. This one also, if you tighten it too much, will break my table. Yeah. So the forces here are really not negligible. Well, the next step is to align this thing properly. Well, the diameter of this body is 123.6 millimeters, so the radius is 61.8 millimeters. So from this edge here to the center, it should be 61.8 millimeters. Well, how to set this up? I will use this. This is a 16 millimeter thick thing, and I will just simply put it into here. When it now goes into there, okay? Like that. Let's put this on 3 gear so I can rotate it a little bit. Then lift the table a little bit. I think there you are. And then I have this piece of office paper which I'm pulling here in between, and then I'm just moving this direction until I feel drag. Not yet. Okay, should be quite soon. Okay, now it's dragging all the way. Not now. Not now. Okay, there you are. Now the edge of this is 0.1 millimeters away from that surface. Aha, okay. So I lock this direction, zero my dial here. Then I need to get rid of this again. I don't want to have it here now. Oh, yeah, okay. Now, since this is 16 millimeters now, this is okay. I can already like the 0.1 millimeters of the office paper. I can put it here in the dial already. So now we need to move 61.8 plus 8 millimeters. And where is my calculator? So it will be 69.8. 69.8. And that will yield how many turns? 69.8 divided by 4. 17 turns. 17 turns. Okay. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ytoo, kaatoo, kootoo, viitoo, kuutoo and 17. There you are. Now it's that much. 17 times 4 equals 68. So 1.8 millimeters more. 1.8 millimeters more. So that's 1. 0.2, 0.4, 0.8. And that's our Y. We don't move it anymore. That's in the middle at the moment. Well, okay, I will reset my dial here anyway. We need to move it actually later on. We need to move it sideways because we are doing 5 holes here. And now the same thing is about this edge. Well, in this case I won't be using this. I will be using another tool for this one. So, well, as it happened, the distance of the hole from this surface here is 10 millimeters that way. Well, the line I made with the scratch I made here is exactly 18 millimeters, or quite near. And the holes in the piece are, it's going here this way. So this distance here from the center of the hole to this surface is 8 millimeters. So it's 18 minus 8, 10. Okay, since this thing is, well, it's 60 millimeters in diameter, first we need to move the table this way, like 3 millimeters. 1, 2, and 3. Yeah. Plug it there. And then we need 10 millimeters more. So that was 4, that was 8, and then 9 and 10. There you are. Then I lock also the X. And the X should not be moved anymore. That should be exactly in place and it stays all the way for all the holes. Okay, now, so well, this is a 6 millimeter carbide end mill. What I'm going to do are flats there, so I can drill the tapping size for M6. So therefore, I first start with a 6 millimeter end mill. I really hope that this reaches all the places it needs to. Let's put it a little. This is a little bit flimsy, but we don't need a lot of. Well, yeah, okay. So this is now the first one. Let's see about the speed. How is our speed? Oh, well, it's okay. So I make actually 5 flats here. So they are spaced like 20 millimeters from each. And I'm a little bit afraid about the last one here. It might, hopefully it reaches. Well, if it doesn't, I'm basically screwed. Okay, let's see. Now let's make the holes. Now we have the 5 flats there. And then we just drill the holes. Now this is a 5 millimeter drill. And it's the tapping size for M6. So I will drill these, but not through. There is a bearing inside there, and it would ruin my day and my bearing and the drill. Well, that would not be fun at all. So I actually measured the thickness of this wall like this, and it's well, it's 19 millimeters here. So I will go when the tip touches that surface, after that I will go in 15 millimeters. Okay, so 10 turns. It's done. Wow. Well, this is a Morse 2 adapter, which I put here, and then I knock here a little bit so it goes inside there. Now it's there. And then I put it here. But let's see whether we don't have a lot room here. This is already like, well, hopefully we can do this. This is really in the edge of not being enough. Man. Well, I have this type of wrench because this doesn't have, well, it doesn't have a center in there. So let's see, this hole, that's okay. Let's see. Man, this might be a problem. Man, how do I do this? This is what I ended with. It's a, well, a pin. This pin goes exactly, well, here into the hole, and it guides the tap, hopefully. So when I put it here, it should guide it. Yeah, of course it does. And now we have enough room here. just need to get this in the neighborhood. Yeah. I don't want to squeeze this. Just put it near enough. There it is now, near enough. Near enough. So this is the first thread. Let's see. Oh man. Done. Okay, I did put this together just to keep it clean. Of course I removed all possible chips so they don't go into the bearings. And now, and then what I did off the camera, I cut suitable screws here. And now I will attach this into its place. Let's see. Have to keep track of these screws. They are all a little bit different lengths. Yeah. So this goes this way into here, and the screw goes here under. Wow, I think it will fit really tight now. Oh, now the interesting part, whether this place is correct. And it is. Yeah, it's 1 millimeter that way a little bit, but that's not a problem. Here we are now. This is actually running, and I think this succeeded in a way. There is a little bit of binding going on, and I have let it run, and the binding is gradually going away. It might be that inside there might be a chip. It only needs a minor chip inside there, and then it starts binding. But other than that, at least it rotates. And it's quite powerful when it's not binding. Yeah, okay. But I will let it run overnight and see what it looks like in the morning. Yeah. It works. Yet it's a binder a little bit. I don't know what's the reason for this, but sometimes it really binds. let it run. Maybe the binding goes away. It wears in. I don't know. It shouldn't. So, but anyway, in the next episode of Finno Machine, we will be we will be making a food for that one. It needs a food so that you can use it. Till then, bye!